Hi everyone, myself Fatima Herman. My teammates are Srushti SS, Amulya BN, and Vaishnavi K. Reddy. Today we are going to discuss about our assignment topic, creating an experiment to analyze and evaluate recursive process creation and its impact on system resources in Unix and Windows. Our objective in this assignment is to create a program that continuously spawns child processes in an infinite loop for three conditions. The assignment will be conducted in both Unix and Windows environment. Our goal is to observe and document the system's behavior, limits, resource consumption, and any errors encountered due to continuous process creation. We are going to discuss about level 1 experiment, that is basic process termination. Each child process created by the parent displays its PID and terminates immediately. This program creates a new process in an infinite loop. Each new process is expected to run an executable named childprogram.exe. It demonstrates process creation using the Windows API create process. The process can be testing the system's capacity to handle processes and concurrent processes, observing process behavior, or debugging child program execution. However, this program may strain system resources due to infinite process creation.
So I'll be explaining about the code basic process termination in Windows systems. So the first line says include Windows. This perform three operations. They are it used for creating process handling threads and other OS level operations. The next line include stdio.h, like provides declaration for input or output functions like printf. Then the int main. The main function serves the program's entry point. Then while creates an infinite loop continuously executing the code block inside. Then the startup info SI declares a startup info structure that provides information about the main window for a new process. Then process information PI. Like this defines structure to store information about the newly created process including its process ID and thread handling. Then zero memory SI size of SI. Then sets all bytes of the SI structure to zero to ensure it is initialized properly before use. Then the next line SI in .cb is equals to size of SI. Sets the CB structure size member of SI to its size which is required by create process. Then zero memory and PI size of PI. Sets all bytes of the PI structure to zero for similar reasons as above. Then the next line, create process calls to start a new process. Then null, no application name is provided. So the second argument, child process extension, is treated as the command line. Then child program extension specifies the executions to run. Then null comma null, security attributes for the process for thread and defaulted here. False. The child process does not inherit handles from the parent. Then no special creation flags. Then and SI pointer to startup info for startup configuration. Then pointer to process information to receive process and thread information. Like the function returns true on success and false if it fails to execute. Then printf create process failed. So if create process fails, get last error, retrieves the error code. Then return exits the program with a status code of 1 if process creates to fail. Then printf child process if create process succeeds prints the process ID PID of the newly created process for track link. And the next line close handle. So closes the handle to the newly created process. This does not terminate the process but releases the handle resource in the parent program. Then close handle. Close the handle to the primary thread of the new process similar to the process handle. Then ends the while loop iteration, then return 0. Ends the program execution with a status of code 0, which means a success. The, the code executes with a 0 error. So this is the output for our code.
The key concepts of this program are startup info and process information. These structures are crucial for configuring and retrieving information about processes. In create process, a versatile function for creating processes on Windows, allowing detailed control over how the new process is started. In resource management, close handle ensures handles are not leaked, which is critical in resource management. In infinite loop caution, the program creates processively indefinitely which can deplete system resources and cause a crash or hang. The real world use cases are stress testing the operating system, observing how the system manages many concurrent processes, debugging or monitoring child program.exe.
Now I'll be explaining the purpose, key concepts, and key differences of the Linux program. This program continuously creates new processes using the fork system. System call in an infinite loop. Each child process prints its process ID, PID, and it exists immediately. The program demonstrates process creation in Unix-like systems. Its purposes might include stress testing, system process handling capabilities, or experimenting with process behavior. However, running it can quickly exhaust system resources due to an infinite loop of process creation. Now I'll be explaining the key concepts. Fork, a system call that creates a new process child by duplicating the call process parent. The parent and child process execute the same code following fork, but their PID values differ. Child process receives PID equals to 0 from fork, executes the code in the else if PID is equal to 0 block, then terminates using exit 0. Parent process receives the child process ID from fork and continues the while loop. Get PID retrieves the process ID of the calling process. Then the key difference of Linux program. First one is system call difference. The Windows program uses create process, which allows specifying a completely different program child dot extension for the child process. The Linux or Unix program uses fork, which creates a duplicate of the parent process and continues execution from the same point. Error handling. Windows program uses get last error for debugging, while Unix or Linux uses sparer. Resource management. The Windows program explicitly closes handles for the create process. The Linux program depends on the child process existing immediately to releases the resources. Platform dependency. The Windows program is platform specific due to the use of Windows API. The Linux program is platform specific due to the use of complement system calls.
Here, if we break down the code, first line of the code provides a declaration of for input and output functions like printf, and second line of the code includes the declaration of prefix happy function like fork and get PID, and third line of the code declares the types like PIDT used for process IDs, and third one will provide a utility function like exit for the program termination, and third line defines main function and program entry point, and sixth line provide it starts an infinite loop continuously executing the block of the code inside, and seventh line it calls the fork system function to create a new process. Fork returns to the twice to parent process and the child process. At child process it will be at the zero, and fork fails if it turns if the fork fails and it returns to the minus one, and if it fork is checks if eight line tells us checks if a fork failed, that this can be happened if the system cannot allocate the resource for the next process for new process, of course. And ninth line prints an error message describing why fork is failed based on the error value. Exit 10th line it terminates the program with the status of a code of 1 indicating an error. Else 11th line of the code this block executes the child process because fork returns to 0 to the child, and 12th line it prints the child process using get PID, which retrieves the process own ID. 13th lines it terminates the child process with a status of code 0 indicating successful execution. This ensures the child do not enter an infinite loop. And 14th line the loop while loop as iterated. And 15th line It returns to the main.
The overall conclusion of the assignment is the two programs demonstrate process creation in different operating systems. Windows and Linux both use system specific methods to create child processes. Create process for Windows and fork for Linux. Despite the difference in their APIs, both programs continuously create a new process in an infinite loop, which can lead to system resources exhaustion if not controlled. The Windows program is more complex, utilizing create process to span external programs, while the Linux program uses the similar fork system called to duplicate the parent process. Both programs highlight the potential for resources overload when creating process without limitations, making them useful for system testing but risky to execute without modifications to limit processes. In practice, these programs can be used for stress testing or educational purposes to explore processes creation and management, but caution it necessary to prevent negative impact on system performance. Thank you.
Thank you.